Guys. So yesterday we were working on this spreadsheet. So what we created was a quick spreadsheet where we could update different values in here. So we have starting values, we have delta values. Recall what the starting value did. It just entered the value that we would start with here in this X value column. So that shouldn't be a huge surprise. And then here in this delta column, or the second value is calculated by taking the initial starting value, here is E5, plus H dollar sign 2. And again, what we talked about yesterday with that dollar sign is that made sure that whenever we pulled our formula down, we were always referencing this one specific spot. So even though when we took that formula, we clicked on the corner and we pulled it down, it would say here in this cell, it would take and it would reference the cell above it. So that E cell got bigger and incremented. It always pointed at that one H cell. It always pointed at that one delta. So the dollar sign was really useful there. Right. Then yesterday, we also found these Y values were calculated just by plugging the X values into an equation. And then we developed this differences column, which we found just by taking the value here right next to our differences minus the value before. Right? The reason we did this sequence is because logically, if we went from a y value of 1,331 to a y value of 900, we see that we're decreasing. So by having the subtraction in that sequence, we see a decrease would correlate with a negative difference. Okay, so that was kind of the spreadsheet buildup. So if you ran into issues with the buildup and you're not seeing values like this, pause the video, double check, and make sure that you are able to create this calculator and make sure that it works. At that point, we picked up with trying to find interesting locations. In particular, what I'm seeing here when I look at the differences column, here, I'm going to highlight kind of across this band. Notice when we have a difference of negative 23, that meant that the function was decreasing. Here we had a function or a difference that is positive 3. So that means that our function goes from decreasing to increasing. That point where we change from decreasing to increasing is what we would call a minimum. So the first task that we were left with yesterday was to try and find the x value of that minimum to at least 2 decimal places of accuracy. Right? So from what we have on our current calculator, we know it's between -3 and -2, but we don't know anything more precise. So what we did in class was we played around. We changed this to like -4, right? And ultimately, what we started to get to yesterday was if we wanted to be more precise, we needed to make our deltas smaller. So if I have my starting value of -4, my delta of 0.01, if I scroll down, notice here, at least on this table, all that I see across this difference column are negatives. That means that I'm not seeing, of course, my change from decrease to increase. So I'm going to come back here and I'm just going to make my starting value a little smaller. I'm going to try maybe -3.9. And notice how a little bit of trial and error. See, I'm getting closer, still not quite there. So -3.7, say. So you can play around. This is a great way that spreadsheets can be used, is just to help with some calculations whenever you don't have a great number answer, but you're just kind of in a ballpark, right? Trying to do all of these things by hand, there would be a lot of calculation. But here I'm able to just kind of quickly change numbers, and I can get that if I have a starting point of -3 and a delta of 0.01, notice here I can see a transition right in here from a negative difference, which would mean decreasing, to a positive difference, which means increasing. So that means that my minimum is somewhere between -2.67 and -2.66. So there we only have 1 decimal place of accuracy. Notice both of these have the -2. and both of them have the 6. We only have one decimal place that's consistent between those two. We want to try and get 2 decimal places. So the way that we will refine this is we'll change our delta and we'll make it 0.001. Okay. And again, we can go through exactly the same process. Now, I know my answer should be somewhere between the negative 2.66 and 2.67. So I'm going to try like negative 2.68, right? Because that'll get me in the right ballpark at least, right? But again, trial and error. You can just kind of work until you find the differences that work. Notice here, we look at our table, I see my last decreasing, my first increasing, and here I see that the x value is negative 2.667, negative 2.666. This would tell me that the x value of that minimum is at, the x value of minimum is negative 2.66. Okay. Now, obviously, there would be more decimal places that would come, but if our goal is to get just 2 decimal places, there we are. Okay. Now, from there, we can also start to take a look at finding the x value of the maximum. So here, if I come back up, I'm going to restart just like we did at the beginning. I'm going to go negative 10, I'm going to go positive 1. Remember, here is where the function is decreasing. Okay, then here we changed to increasing, so that meant that we had our maximum between negative 3 and negative 2. Our previous work told us that it was negative 2.66. But now notice we do have one more change that occurs right here. Notice when x is 1, we are increasing. When x is 2, we are decreasing. So if we go from increasing to decreasing, we pass through a maximum now. Okay, so what you guys need to try and take a look at now is how do we find the location of that maximum? So I'm going to I'm going to encourage you guys to take a moment, pause the video, try and go through and see if you can find the location of that maximum or the x value to 2 decimal places of that maximum. Then we're going to go through how we can set this up. So I know it's between 1 and 2. So if I start off with 1, if I want 2 decimal places, I'm going to use that 0.001 difference like we had before, because that 2 zeros after the decimal is going to correspond with the 2 decimal places of accuracy we want. Now, unfortunately here, I see all negatives and they're getting bigger. So I'm actually going to make this a little bit smaller. Choose a slightly smaller number. Notice here I have all positives, a little bigger still, all positives. And notice these positive numbers are getting a little bit smaller as we go along. See positives. Again, whenever I go to 1, it goes negatives. So that means it must be somewhere between that 0.9 and 0.5. So here, if I do 0.95, notice I'm still all positives. I'm going to try maybe 0.97. Notice here, my differences are positives, which mean increasing, and boom, here we go. Notice a transition. So positives mean the function's increasing, negative means the function's decreasing, and we see that that happens between 1 and 1.00. So what that would tell us is to 2 decimal places, that maximum where we go from increasing to decreasing, that occurs at where x is 1.0. So the x value of maximum is 1.00. Now, what we'll be asked to do here as we work through some of these problems today is we're going to be asked to describe some intervals where the function is behaving a certain way. So here, if you look, this second question here says the function increases on only one interval. So update the starting value in data field, so is exactly what we were doing, to estimate the interval to 2 decimal places. So notice we just found that the minimum is at negative 2.66, the maximum is at 1.00. The way that we can describe this interval is we can write negative 2.66, comma, 1.00. I know this looks a lot like an ordered pair, but this is actually an example of what is called interval notation. In interval notation, what we do is we give the x value where the behavior begins first, and then we give the x value where the behavior ends. So between this minimum at negative 2.66 and this maximum at 1.00, the function was increasing. Now, everywhere else, the function is decreasing. So if it's only increasing in one place, it's decreasing in two places. So here we can give the interval where the function is decreasing in a very similar way. It's going to be a slight modification because what we would say is forever off to the left side, we would indicate that by writing negative infinity. So here I'm just going to do 0, 0, negative 0, 0 to indicate infinity, all the way up to negative 2.66. That's where the function was decreasing, okay, because it decreased all the way down to that minimum. Then the function increases from negative 2.66 up to 1, but then the function is going to decrease again from 1 on to infinity. So whenever we actually have two answers, the way that we'll write those in interval notation is we'll write each of them as separate intervals. So I'll write 1 comma 0, 0. That's the positive infinity. That's the second interval where this would be decreasing. And the way that we glue these two answers together is we join them with what's called a union symbol, which here we can just denote with a capital U. Okay, this is how we would describe the interval where this function is decreasing. So again, the function's increasing here and it's decreasing here. Okay. Now, what you'll be able to do here on this second slide, you switch over to the second tab, is here we'll have exactly the same sorts of functionalities built in. The only difference is what we're going to be working on is now we are going to need to be able to update a function to create our own y values. This is going to be really beneficial because this will be the calculator we can use to do our practice problems. So take a moment, pause the video. Again, try and fill in your starting value, your delta, get your x column. And then we're going to talk about how to fill in the y column. Okay, so the important thing with the y column here on this is going to be very, very much like what we did with that vertex formula calculator on our first spreadsheet. What we want to do is we want to take every value from this y column and we want to substitute them into a function. Now, this is going to be something that you're going to have to do a little bit more manually than what we had in our first calculator. So here, let's just set it up for this function, x to the fourth minus 5x cubed plus 6. If we want to find the y values of this function at this value of x, all that we're going to do, again, we'll press equals so the spreadsheet knows we want it to calculate something. Everywhere you see an x, we'll choose the box that's off to the left. So I would need x to the fourth, so my x value raised to the fourth. Again, up caret will give me the exponent. And then minus 5 times x to the third. So notice again the importance of using the asterisk for multiplication, and then plus 6. Okay, so everywhere there was initially an x, I chose this value. If I hit enter, it updates that formula. Now, here the great thing, what I'll be able to do is I will be able to just take this corner and pull it straight down, And now this will calculate all of the y values of this function. Okay. And again, every cell, if you look here, notice it's just going to point at the x value that's immediately to its left. Okay. That's where that pull down function can be fantastic. Okay. Calculate the differences in the same sort of a way. Again, we can pull the formula down. And just like before, take a quick moment and see if you can respond to these three questions before we move on.